Okay, hi everyone, and welcome to another mini presentation for your weekly assignments for the subject Principles of Computer Graphics and Image Processing. This weekly assignment and the mini presentation is focused on drawing a curve, more specifically Bezier curves and using Custojal algorithm. Again, as the last week, this is a sort of English translation and a little bit enhancement to already published presentation from Martin Maderas, and you can find it on his webpage. So, moving on. We last week learned how to draw lines, only straight lines, but the real world isn't created only by lines. We sometimes want to create or draw a curve. And to do it properly, we need some sort of algorithm. And there are many curve drawing algorithms. Maybe the most simple one is midpoint circle algorithm. If you want to draw just a circle, it's very similar to Bresenham line drawing algorithm. It also uses only integers. You can find it, you can try to learn it. But tonight we are going to learn about Bezier curves and how to draw them. I'm gonna start with simple Bezier curves, or actually Bezier drawing line, and then I will go further just to understand the basics and how it works and how simply could it be to implement this algorithm. So what it is actually, I would really like to say that drawing a Bezier curve, actually using the Custojal algorithm, if you want to learn about the history of this, why it's called Bezier curve and the Custojal algorithm, please find it on Wikipedia or just watch the lecture. So, back to the algorithm, we are trying to draw a curve, actually a parametric curve, that is defined by some control points. I really like to call the Bezier curve as an inception of drawing lines, because how to simply describe it? Every Bezier curve is defined by 3, 4, n key points, or the control points. Here in this image we see 4. And what we actually do is we are trying to recursively compute a parametric point on the same distance between each of these control points, and then recursively between the created ones until we have only one point that we can't no longer interpolate with any other. So that's why I called it inception, because we're going always deeper. We get between these 3, we get between these 4, then between these 3, and then between these 2, and now we get the last point for the Bezier curve. So, just start from the very simple one. We can define a Bezier curve actually as a line. And we can draw it just by having 2 control points, and then a parameter that is computing the points where should this line points should be located in coordinates. That is very simply defined by this equation, and we can see that we start from point 0, go to point 1, and just increase the parameter. And by that's called interpolation, just going between 2 points. And sure, we can draw a line like this. But if you want to draw a curve, a simple one, as a quadratic Bezier curve using only 3 points, we interpolate between the first 2 control points, then between the second 2 control points, the control point 0 and 1, and then 1 and 2. We get, we get another 2 control points from these 3, and then we again interpolate between these 2, and we get point on the actual curve we want to draw. But it is more optimal to draw a Bezier curve not with 3 key points but with 4 key points, and we are drawing cubic Bezier curve. So again, interpolation or the inception, we get 4 control points with 3 lines, we interpolate between them, we get 2 lines with 3 control points, and we are back to the quadratic Bezier curve, and then interpolate between these 2 lines, we get 1 line, and interpolate on this 1 line, so we get back to the linear curve, and we actually get the last point that is defining our final curve we wanted to draw with these 4 points. As we see, drawing the line by this parameter, we can set the counting not to be just 1/100th, but to be even lower or higher, and to define how many of these sections or the points on the line we use defines the smoothness of the line. Well, in the line it doesn't matter, we need only just 2, but if we get to the quadratic curve or the cubic Bezier curve, we see that the more the portions of this line, then by drawing lines between these points, these are the last control points of the Bezier curve, we can create it much smaller. If we use only, I don't know, 5 points or 10 points, we get points only on certain positions, and it would be not a curve but actually a polygon. So there are higher order Bezier curves. We can be drawing many crazy curves with this many points. You can already try it. It's actually fun. Yeah, actually at least it looks fun. A kind of cycle. And yep, that's it. We are getting to our weekly task. So we now know that the Bezier curve is actually just interpolating between control points. So how we actually draw the Bezier curve is by decreasing the number of control points defined by us or someone who is trying to draw these curves, and getting from the quadratic control points quadratic curve to just drawing some sort of a line, but actually it's not line, but getting only 1 point that defines the curve we want to draw on canvas. So what is your weekly task? We want you to draw, or actually to implement a Bezier curve drawing algorithm, but use the Castells algorithm, and use OpenGL commands to draw it on canvas. So you don't have to use your drawing algorithm from previous week. We want you to use the OpenGL command to draw the actual lines between your computed control points. You can find these commands in GL1 gradient. You can inspire there, but it's not actually the last one. The final one, there is something different I can show you later. And to implement the task, first define the curves of Bezier control points, generate and store line points, the final line points when you interpolate or get to the inception of the last point, and store them in std vector, and then use them to draw lines between these stored points using OpenGL function. Okay, and the actual implementation, if we take a look at the code, you can find it in task 3 Bezier. There are some headers, also using shader. So we are not drawing an image that should be saved as a BMP or something, but we are trying to draw it on canvas and then show it in a window. Here in the In the implementation, you have control points defined for letter R, and it's actually by defined by 4 control points, so it's quadratic Bezier curve. So you can try your implementation using these control points. Then of course you have to define your control points defined by your weekly assignment. So as you can see, you have std vector defined for points that should be used for the Bezier curve geometry, and you're going to fill this vector with your generated points. And now you can see we are using a shader that is using defined shaders in the GLSL header, or actually the GLSL file. So here we have predefined function for Bezier drawing algorithm, Bezier curve drawing algorithm using 4 input points, but you can change it as you like, defined to your weekly assignment, and here you will code the actual program your actual drawing algorithm. Here is the actual function that will call the Bezier point, and as you can see, and it's defined here, it will take each 4 points and moving by 3, so it's how it's defined in the structure. You can go here, like these 4 are the first Bezier curve, and the last point is also for the next 4 control points. Again, the last one is for the next 4 control points, and the last one is for the next control point. So we can see there that letter R is defined by 4 lines. First one, second, again, third, and the fourth. Okay, that of course depends on how your assignment will be. If you have to draw it by 5, 6, or all of them together, it is defined by your weekly assignment in the Google Classroom. And then we have it here. You have to somehow write the control points to the array buffer and say OpenGL to draw it on canvas and to the canvas. And here we can see some definitions for the model matrix, projection matrix, and how the color would be set of the drawn image, the actual lines. Here on idle as the function that is used to draw the objects on the canvas, and it's always called in the loop, and that's why we can use it to change the scene, draw something new in the scene, or actually always redraw what we want to show. But sometimes it's better to first compute our own control points and not compute them always in the cycle. So first it should be defined in the constructor, that how we want to generate the key points of the line, and then send them to on idle just to draw them on canvas. Sure, you can do it all together, I mean just compute it and draw it and everything in the on idle, but the computations might slow down the actual drawing algorithm and the FPS of your program. Okay, so I know there is very many more things that you were used in previous videos and previous tasks, but don't worry, you can use GL1 gradient that uses a few of them, but in a different way. So try to read it carefully, watch it what's defined here, and try to draw with the correct setting. Okay, that's it. If you have any questions, please ask them, and again, good luck.